Let's talk about the conjugate pairs theorem. We're going to be working with polynomials, and as we are factoring these polynomials, we're going to get zeros that are in the form a plus bi. And our conjugate pairs theorem tells us that if we know that a plus bi is one of our zeros, then another zero needs to be a minus bi. Both of these would be imaginary numbers, and they're not going to be seen, the intercepts are not going to be seen on the graph when we're looking at our polynomials. So let's take a look at an example here. We have a polynomial of degree 5, and we know the zeros are -2, -3i, and 2 plus 4i. And we want to find the remaining two zeros. Well, if we know that we have degree 5, then we know we should have a total of 5 zeros. So as we're taking a look at our list, one of our zeros is -2, and this would be an example of a real zero. If we were graphing the polynomial, we would be able to see our graph either cross or touch at that x-intercept of -2. We have a second zero that is -3i, and this would be an example of a complex zero, or imaginary. And we know that our complex zeros come in that form a plus bi and a minus bi. Our a value here would be equivalent to a 0. So if we know that we have this x-intercept of -3i, then the pair that goes with it is going to be a positive 3i. And our last zero that they gave us was 2 plus 4i. This is an example of a complex zero. Okay, it's in that form a plus bi. So the pair that goes with it is going to be 2 minus 4i. So the remaining two zeros that we were looking for are the positive 3i and the 2 minus 4i.